Hey everybody, Mr. Rivers is back here. Week 2, class 1. Go ahead and pause the video. Try these 4 warm-up problems on your own. Pause the video now, please. All right, I'm going to take a look at the equations first, these 2 problems first. Remember, we're trying to get the variable isolated by itself and trying to get all the constants on the other side of the equation. So looking at the first problem here, I notice I have a variable on the left side, constant on the right side. So I'm going to move this constant of 6 over to the right side. This is a positive 6. What is the inverse of positive 6? It is subtracting 6. Remember, this negative sign here belongs to the 5x. So when we subtract 6 from both sides, we end up with negative 5x equals 15. Now, to get the x by itself, the negative 5 and the x, they're being multiplied. What's the inverse of multiplication? It's division. So we're going to divide both sides by negative 5. And when we do that, we get x equals negative 3. Now we can check this by subbing it back in. Negative 5 times negative 3, that's positive 15. 15 plus 6 is 21. Take a look at the second problem here. We're going to apply the distributive property first. And when we do that, we get 4 times x is 4x. 4 times 5 is 20, so 4x plus 20. The plus 8 gets carried down here. X plus 3 gets carried down as well. Now, we're trying to combine like terms. I notice I can combine 20 and 8. 20 plus 8 is 28, which gives us 4x plus 28 equals x plus 3. Now I'm going to get the variables on one side, constants on the other. Doesn't matter which side you get the variables and which side you get the constants, but you do have to separate them. So I'm going to get the variables on the left. So I'm going to move this x on the right side over to the left. And I'm going to move this constant of 28 over to the right. We subtract x from both sides and we get 3x plus 28 equals 3. We're then going to subtract 28 from both sides. When I do subtract 28 from both sides, we get 3x equals negative 25. Now we need to, now we need to divide by 3. When we do that, we divide by 3 and we get negative 25 thirds, or if you wanted to make it a mixed number, negative 8 and 1/3. All right, moving on to the next two. On the first problem, we're going to divide both sides by negative 12. When I divide by a negative, I do have to flip my sign, so I'm going to rewrite all of this. So we divide both sides by negative 12, and we flip our sign at that step. Negative 24 divided by negative 12 is 2, so x is less than or equal to 2. Looking at our second problem, we want to get all the variables on one side, all the constants on the other. I've got a variable on the left, I've got a variable on the right, constant on the right as well. So I'm going to move this variable from the right side over to the left and away from the constant. I'm going to do that by subtracting 2x from both sides. Well, we subtract 2x from both sides. 2x minus 2x is 0. 7x minus 2x is 5x. So we're left with 5x is less than negative 25. We divide both sides by 5. Now, are we going to flip the sign here when we divide by 5? No, we're not, because 5 is positive. We only flip the sign when we divide or multiply by a negative on both sides. All right, so we divide by 5 and we get x is less than negative 5. Today we're going to talk about section 9.5. This is ratios and rates. The objective of today is to write ratios as fractions in simplest form. Keywords are simplest form, and to determine unit rates. So as a ratio is a comparison of two numbers by division. It's often expressed as fractions in simplest form or as a decimal. There are several ways to write ratios. 5 divided by 2, that is a ratio. 5 divided by 2 this way, that is a ratio. You might look at that and say 5 to 2 as well. Or this way, 5 to 2, that is a colon, 5 to 2. These are all ratios. So if you have $10 and your friend has 4, the ratio of your money to their money, 10 to 4, which simplifies to 5 to 2, right? 5 to 2, 5 to 2, 5 to 2. These are all ratios. Ratios express each ratio as a fraction in the simplest form and as a decimal. So first off, 6 free throws made out of 10 attempts. Well, if you made 6 out of 10, that's 6 over 10, 6 divided by 10, which is 3 to 5, which as a decimal, 0.6. So 6 free throws made out of 10 attempts is 3 to 5, or 0.6. Take a look at the next one on your own. 3 broken eggs out of 12 in a carton. So pause the video now, work on the next example. So 3 broken eggs out of 12, that is 3 divided by 12, or 1 divided by 4, or 1 to 4. Another way to think about this is 1 out of every 4 eggs is broken, or 0.25. Try this one. $25 tip on a $125 meal. What is that ratio as a fraction in simplest form and also as a decimal? Pause the video now. Well, 25 divided by 125 is 1 to 5, or 1/5. Another way to think about this is for every $5 of food, you paid $1 in tip, which is 0.2 as a decimal, or 20%. So you paid a 20% tip. All right, try this one out. $375 in commission to $9,375 in sales. Use your calculator if you need to. Go ahead and give this one a shot. All right, so 375 divided by 375 divided by 9,375 is 1 to 25, or 1/25, which is 0.04 as a decimal, excuse me. So there you go. So a rate is a special type of ratio. The difference is a rate has units of measurement. So it's a comparison of two measurements with different units of measure. So example, miles per gallon. So you've heard that before in terms of driving a car. If it gets 10 miles per gallon, that is a poor rate of return for your how much gas you put in your vehicle. You don't go very far based off of how much gas you put in. So miles per gallon, or cents per gram. So if you go to the grocery store, if you're comparing two items of different size, maybe the small item is on sale and the big item is not on sale. At Kroger, I know they will show you the price per ounce, the price per gram. That's the unit rate that you are looking for. The lower the unit rate, the cheaper it is. The higher the unit rate, the more expensive it is. So here's some more rates. Soup at 89 cents per 15 ounces. Gas is $3.19 per gallon. These are rates. The unit rate is a special type of rate. It's a rate with a denominator of 1, so miles per gallon. How many gallons are we talking about? Well, if you're getting 25 miles per gallon, that denominator of gallons is 1, miles per 1 gallon. Or if you're at the grocery store and it's 4 cents per ounce for some type of cereal that you buy, or that might be actually pretty cheap. I don't know, 10 cents per ounce, let's say. That ounce is in the denominator and is per 1 ounce. So you have a denominator of 1. So let's work this first one out together. 99 cents for a dozen. We're going to find the unit rate, which means we need to have a denominator of 1. So let's write this out. And I realize we're missing a second unit here. So 99 cents for a dozen, and I just made it eggs, so it could be a dozen of anything, but 99 cents per 12 eggs. So we need to divide here. And your calculator comes in pretty handy, and we get 8.25 cents per egg. So 8.25 cents per 1 egg. So our denominator is 1 here. All right, try this next one out here on your own. 45 meters in 3 minutes. So find the unit rate here. Write it out as a fraction like I did. Divide it out and find out what your unit rate is. Include the units of measurement, because remember, rates include measurements. This is important that you have these in here. So go ahead and do that now. Pause the video. Find the unit rate. So 45 meters per 3 minutes. We divide this out. 45 divided by 3, we get 15. So 15 meters per minute. 15 meters per minute. Try this next one out here on your own. $300 for 5 jackets. Pause the video now and find that unit rate. So $300 for 5 jackets. We divide 300 by 5 and we get $60 per jacket. $60 per jacket. That is your unit rate per jacket. Last one here, 12 pounds lost in 5 weeks. Find the unit rate of that one. Pause the video now and find the unit rate. Okay, so 12 pounds in 5 weeks. 12 pounds divided by 5 weeks. We divide that out. 12 divided by 5 is 1.5 pounds per week. There we go. So unit rate is really handy when it comes to comparing prices. Kroger, as I said, already does this. They put this information on their price tags at the store, so you can compare different sizes to large, like smaller sizes to bigger sizes, and look for the cheaper unit rate. So the lower the unit rate, the cheaper the item is per ounce, which means you're getting a better deal, right? So you can buy a 12-ounce box of cereal for $3.29 or an 18-ounce box for $4.89. Which box is the better buy? So what you need to do here, find the unit rate of the 12-ounce box, dollars per ounce, right? Find the unit rate of the larger box, dollars per ounce. Dollars will be the numerator, ounces the denominator, and compare the unit rate. So go ahead and pause the video and do this now. All right, so we find the unit rate of the smaller box, and we get 0.274. That would be 27.4 cents per ounce. And the larger box is $0.271 per ounce, or 27.1 cents per ounce. So notice that the larger box has a smaller unit rate, therefore the larger box is the better buy. There we go. The 18-ounce box is the better buy. All right, last one. Try this on your own. You can buy a 16-ounce jar of peanut butter for $3.19 or a 12-ounce jar of peanut butter for $2.49. Which is the better buy? Pause the video now and give this one a shot. All right, so we find the unit rates of each. The 16-ounce bottle is $0.199 per ounce, or 19.9 cents per ounce, and the smaller bottle is $0.208 per ounce, or 20.8 cents per ounce. So the cheaper bottle per ounce is the 16-ounce bottle or jar. All right, the 16-ounce jar is the better buy. There you go. That is my time. Thank you very much for your attention. Make sure you go back to Google Classroom and complete the assignment that is there.